Okay, so for dissection 5 we're gonna design a reduction gearbox. Unlike the previous dissections, the part that I'm gonna dissect is not a base design for reverse engineering. This is just an example of an industrial reduction gearbox. So these gearboxes typically used in high power applications such as industry assembly lines or small electric vehicles. So this is the input of this gearbox, and here we have the output. And you can see I'm rotating the input, but the output is rotating way slower than the input. So the rate of this reduction gearbox is 130. You can see the ratio is 30. So as you can see, the rotation axis of the input and output, the angle between these rotation axes is 90 degrees. And there is an offset between these two axes. So you can see from here there is an offset here. So if, for example, this axis was here, there wasn't any offset, but we have this offset. So let's see how it reduces the speed. You can see if I rotate the input, I can see the rotation of output, but it is not reversible. So I cannot have the rotation of this axis if I rotate this one. It's locked. So probably what I have here inside this gearbox is a worm gear. Let's see what we have the inside. You can see here mounting flange. So for example, we want to attach this gearbox to another object. So we use this flange with, for example, some screws to attach it to another object. Let me remove these mounting flanges, and then we can see what we have inside this gearbox. So I think you can see the inside of the gearbox. As I said, we have a worm gear. This is the worm, and this is the worm wheel. You can see the worm wheel here. These are roller bearings. And we have worm here, ball bearing here, and another ball bearing here to support mostly radial and also axial forces. So as I said, you're supposed to come up with an entirely new design for a reduction gearbox, and we will use 3D printers to manufacture the gearbox for you. You can design spare gears. For example, these are 3D printed spare gears. Or even angle gears. And your final gearbox would be something like this. So there are some gears missing here, but you can see, for example, here we have an internal wall or a supporting wall to support this shaft. So you can design supporting or interval walls as well. So let me go through the two options that you have. You should choose just one of them. The second option is to have two shafts, input and output, parallel to each other. So for example, you can have input shaft here and output shaft here. That's fine if you have an offset between them, but you will get a bonus if you can design something like this, collinear input and output shaft. You can see here these two are collinear. Or for option 2, for option 1, you can design a gearbox, a right-angled gearbox like this. Here, as I showed you, we have an offset, so that's fine if you don't have any offset, but you will get a bonus if you can design an offset similar to this. So again, you can see we have this offset. This is the offset here. Okay, that's it. I hope you enjoy working on this dissection, and in dissection 6 we will assemble what you have designed and manufactured.